super excited to come to this video, which is the last video in the mole concept series. Remember students, there is application of mole concept, which is stoichiometry. Stoichiometry combines mole concept and the knowledge of chemical reactions, chemical equations, balancing of chemical equations. So stoichiometry is the advanced level of mole concept, but this is a final video in the series of the mole concept. Today we are going to convert the empirical formula into molecular formula. And just because empirical formula is a little bit tricky kind of topic, I'm going to go over the steps of reaching to the empirical formula, and then we'll connect it to today's work. This is going to be a short video, enjoyable video, because it's short and sweet. Okay. So the question was, find the empirical formula of a compound where the percentage composition is given. Even if the percentage composition is not given, you will consider if it is in just grams. Okay. Do the same steps. If percentage is not given, grams of each element is given, you are going to follow the same steps. Step 1 is this percentage I converted to grams. Then I converted grams to moles. So we divide by molar mass and find the moles of each element. Second step is you find the least ratio of the moles. How do you find the least ratio of the moles? You take the smallest number of moles and divide each measurement by that. Why? Because we consider that the least number of moles, if it's one part, we find out how many such parts of the other elements are present. So here we know that when you divide all of these measures by 3.33, I understand that we have 1 mole of carbon. For every 1 mole, there is double moles of hydrogen, and how many ever moles of carbon? Same number of moles of oxygen. So the least ratio of moles is 1:2:1. Therefore, the empirical formula is CH2O. Now the next step is, how do we convert this empirical formula to a molecular formula? In the previous video, my dear students, you must have learned that molecular formula is nothing but it's a multiple of the empirical formula. Now the only thing is multiple in what sense? Like I gave you the example in the last video, but let's say it's been a while that you have seen the previous video. I'm going to do this one more time, dear students. Suppose I have a compound which has a molecular formula of C6H6. Its empirical formula is CH, right? Now, if I have totally different compound, which is C2H2. Now, C6H6 is benzene. It's a liquid. It's a solvent. Now, there's totally different compound C2H2, which is acetylene. It's a gas. It's used for welding purposes, right? It has many other. It's used also for artificial ripening of fruits. Now, these two compounds are totally different, but the simplest ratio of atoms present in it is going to be C1H1. So, the empirical formula, both of them is CH, but the molecular formula is different. Now, suppose I have been given a question and I arrive at the empirical formula as CH. Now, if I multiply CH by 2, I will get acetylene. If I multiply it by 6, it is benzene. But what exactly is the compound under investigation? So, for that, students, I need to know what is this N that I'm going to multiply so that my empirical formula is converted to the real and the correct molecular formula. Okay? So I hope you're getting this. If not, don't worry, keep watching, you'll get it. So once you've arrived at the empirical formula, molecular formula is the multiple of this empirical formula. How do they find that N, the multiple? For that, we are going to do 2 steps. Number 1, we are going to find the empirical formula mass. Now, how do you find the empirical formula mass? You know the empirical formula, let us say CH, right? So you know the empirical formula is CH, and empirical formula mass is nothing but the sum of the atomic masses. So in this, carbon is 12, hydrogen is 1. So the empirical formula mass is 13. Okay. Let us consider 13 in grams. Okay. Because I am going to use this in this formula where I am going to use molar mass. Molar mass is in grams. So I am taking empirical formula mass also in grams. Now, how do I know the molar mass? I don't know the molecular formula, right? I don't know the molecular formula, so I cannot calculate the molar mass, but they will give you the molar mass in this question. So let us say they say the molar mass is 26 grams. So if they say the molar mass is 26 grams, means what, students? The actual molecule is having a 26 units of mass, whereas your empirical formula has 13 units of mass. Means how many of these 13 units are present in the actual molecule? 2, right? This is 13 and the actual molecule is 26. means it 2 times. So if it is 2 times means our actual molecule is C2H2. Okay, so how do you find the multiple? You take the molar mass and divide it by the empirical formula mass. Okay, don't worry, we are going to see some more examples. So let us look at this question where we arrived at the empirical formula in the last video, which is CH2O. How do you know what is the actual molecular formula? I said step 1, find the empirical molar mass. Okay. So empirical formula mass in grams is empirical molar mass. So I take the mass of carbon, which is 12, take the mass of hydrogen, which is 1, and multiply by 2, I get 2. Take the mass of oxygen, okay, and take 16. That is, add everything, you will get 30. So I'm going to add 30G because we are saying the empirical molar mass, okay, 13G. Now, I know the actual molar mass is 180 grams, means this empirical formula is weighing 30 grams, but the whole molecule is 13 gram per mole. So what do I do then? I just divide. I know that there are 6 such units, right? So 180 divided by 30 means in actual molecule there are 6 units of empirical formula. So I take CH2O multiplied by 6. So I get this number 6, right? And multiply by 6. So that's my actual molecular formula. Okay, let's do one more example. Yeah. So C2H6O is my empirical formula and I want to find what is the real formula, what is the actual molecular formula. So step 1, find the empirical molar mass. So empirical molar mass is 2 times mass of carbon, 6 times mass of hydrogen and 1 times mass of 16, which is 46 grams. The actual molar mass is 90. Okay, so if you take that actual molar mass and divide by 46, you will get 2.1 something. So we approximate it to 2. Okay, so means there are 2 such units of empirical molar mass in this. So the empirical formula has to be multiplied by 2. So the actual molecular formula is going to be C4H12O2. All right, so C4H12O2 is going to be having an approximate molar mass of 90 grams. So that's all about converting empirical formula to molecular formula. I'm sure you're following through. If not, you know what you need to do. Just go back, watch the segment, and if you have not solved it, solve along, okay? And if you've solved it, you have not got it, no problem, solve it again, okay? Because more number of times you'll write, you're going to engage your muscles. And remember students, muscle memory is the longest staying memory. So that's all for today. That's all for this video. That's all for this unit, the mole concept. I hope you are getting this and I'm sure that you're commenting after every video. If there's anything that you want to learn more, you can get in touch with me through my live sessions. We do a lot of practice. Many more questions are done in the live classes. Students, you can actually ask me doubts and I can do the questions that are bothering you. In this video, I can do only the sample questions. I hope you understand that. So that's all. Thank you so much. God bless. And I'll see you in the next videos with so many more important and challenging topics. Bye. Take care.